Class, in this video tutorial I'll be looking at the C++ functions. We'll be looking at the following objectives in this tutorial. We'll try to understand what functions are, how they are defined, how functions are used, and how parameters are passed in C++ functions. So let's start immediately. What is a function? A function is a block of code designed to perform a specific task. A function is a block of code designed to perform a specific task. A function runs only when it is called. A function runs only when it is called. A function may, when you call a function, you may need to pass values to it. These values are what we call parameters. So a function may need a parameter to work, to operate, or to perform its task. It's also optional. A function may also not have a parameter to function with or to perform its task with. A function also may return value after it has performed its task. Also, some functions may also not return value after they have performed their task. Let's look at the syntax of a function. A function has the following syntax: return type, followed by the function name, followed by a list of parameters, and then inside a brace or a block of brace we have the function body. The function body is where the task or the program or the code that makes the function to perform its task is found inside the function body. So let's look at it again. We have the return type. This is a function that returns value. You must specify the type of value it will return. If the function, after performing its task, it will return integer, that means the return type will be integer. If it's going to return float, the return type will be float. If it is double, the return type will be double, depending on the value that this task will return. When it has finished performing its task, you specify that return type. But if a function will not be returning any value after performing its task, then the return type will be void, V-O-I-D. The return type will be void, indicating that when this function is done, it is not expected to return value to wherever it was called from. Then, after the return type, the next thing that follows is the function name. The function name is actually the name that you use to call this function. Function name must also obey the rules of naming variable. It must start with a letter or underscore. It cannot start with a number. It doesn't have a space in between. That is where, instead of having function name separated, you can use underscore to join multiple words. There must be no space in a function name. It cannot also be a keyword, and it doesn't contain symbols. So after the return type, what follows is the function name. Then after that are the parameters. Parameters are the values that the function will need to perform its task. So in trying to specify this function, you give the name of in trying to specify the parameters rather, you provide a type and the variable name of the parameters. The type and the variable name. So if you have two variables or two values that this function may be needing, you may have to say int value 1 comma int value 2 if both values are integer. We're going to look at this when we start writing codes anyway. But after that, the function body contains the body of the function that determines the task that the function will be performing. Is that okay? So let's move ahead. Why do we need functions? Why do we need functions in a program? One, programs often perform repeated tasks. Yes. Sometimes when you write a program, you'll see that a particular body of the code are required to be used at different portions of the program. So when you have such a case, it's a very good candidate for a program that requires functions. So when you have a program that will be needing you to be repeating a particular task at different parts or portions of a program, that program is a good candidate for functions. So writing the same code multiple times, if you have a repeated code, a repeated task, writing them this multiple times increases errors. Imagine after writing this body of code here, because you will need it at another portion of the program, you now duplicate it. At another point, you duplicate it. If you make changes in one, you may not remember to make changes in all. So it increases the chances of errors. Then it makes maintenance difficult. It makes maintenance difficult. So what will function help us to do? How will function help us to resolve some of these issues? One, functions helps us break programs into manageable units. Instead of lumping all the logic of your program, all the tasks that a particular program is performing, instead of lumping them as one block of code, you can use function to break them into separate units. So function helps us to break programs into manageable units. It allows us to reuse our code. You know, instead of having multiple repeated versions of the same code, we can write it once and be using it any other place we needed to make use of that portion of code, instead of rewriting them, instead of duplicating them. So it promotes code reuse. It also helps improve readability and debugging. When you have issue with a program and you find a particular function that is responsible, you can isolate that function, debug it, and other portions of the programs are not affected. And it also makes program readable, because in trying to break a program into functions, you aim at using terminologies that are very related to the problem you are solving. So it makes readability very, very improved and easy. So let's types of functions in C++. We have basically two types of functions. They are the library functions, or what we call the inbuilt functions or built-in functions. These functions come with C++ installed. When you install C++, there are functions that come along with it. They are called library functions or built-in functions. For these ones, they are already good to go. You don't need to do much. All you need to know is how to call them and how to use them. You may not even need to know how it performs its task. All you just need to know, what do I need to give it, that is in terms of parameters, and what do I expect from it, that is in terms of what the return type or return value. So they will also have the user-defined functions. User-defined functions are functions that the programmer writes by himself or herself. The library functions cannot contain every function that is needed to solve a programming problems. So the common ones are found in library functions, while customized functions are written by users or programmers to meet their specific tasks. So we have library functions and user-defined functions. Today we are going to be focusing more on library functions. In our next video, I will venture into user-defined functions. So we'll continue with library functions. What are library functions? Like I said before, they are predefined functions provided by C++. They are stored in what we call header files. They are stored in what we call header files, meaning that before you use them, you must make sure you include the proper header file in your code so that these functions will be included in your program. That means it's not that when you write a program that these functions can be used by your program. Before you use them, you must make sure you include the files that contain them. That's what we call header files. So they are stored in header files. Using library functions helps save you development time, because some of these functions are already written for you. You don't have to write them again. You don't have to waste your time reinventing the wheel. All you just need to do is to use them because they're already there and part of your C++ compiler. Then, apart from the fact that they are there and they make work easy for you, the next thing about library functions is they have been tested and optimized. They have been tested for errors. They have been optimized for best performance. So when you are using them, you're actually taking advantage of a tested and an optimized program. So some examples of library functions, some of them are going to demonstrate in this video. Some examples, we have the cout, cin. Yes, we have been using cout, cin. But you remember that if you don't include #include iostream, if you don't include iostream, you discover that you cannot make use of cout and cin. So cout and cin are functions for performing output and input operations. They are included in the header file called iostream. We also have square root function and power function. There are other functions, but I'm just listing very few of them. The square root function and the power function are for performing mathematical operations. Square root will give you the square root of a provided number, and power will give you the power of a number raised to power a particular number. So these two are included in the header file called cmat. So if you want to use these mathematical functions, you have to include cmat. So you have to do something like #include cmat, cmath, cmat. We also have something like length, append. These ones are string related functions for finding the length of a string or for adding string to another string. This one also come with a header file called string. So if you are going to be using this one, you are going to be saying #include string. Then I also want to look at to upper and to lower. This one converts a character from lowercase to uppercase or from uppercase to lowercase. This one came with a header file called ctype. It came with a header type called ctype. So I have a table. So first of all, let's look at what are header files. Header files contain function declarations. They contain function declarations. You have to make use of them by making the preprocessor invoke them using the #include keyword. So you have to use #include if you want to use them. I've said that before. So let's look at some common header files. Like I said, we have the iostream header file for performing input and output operation. We have the cmat for performing mathematical operations. We have the string for performing string operations. We have the ctype for performing character manipulations or operations. So the code C++. Alright, you can see my screen. I want to first of all demonstrate the cmat function. Cmat function, I have to do #include cmat. Alright, I want to check the square root function. I want to check another function called power, which is POW, P-O-W for power. I also have to check another function called seal for ceiling. I also have to check another function called floor for floor. So let's demonstrate them one after the other so you can appreciate what they do. I will comment the rest while I demonstrate the particular one I am interested in. Remember to comment. Multiple line comment is a \, return this. Then where do I want it to end? I want it to end there, another \. So I just want to demonstrate the square root function. So I declared x. I asked 4. So my output is to see out the square root of x. When I run this code, beautiful. So that the output is 2. The square root of 4 is 2. As simple as that. So just take note, SQRT, all in small letter. Then you provide the value you want it to find the square root. You can also enter the value directly. Maybe I add square root of 16. I'll run it again. Square root of 16 is 4, as you can see. Square root of 16 is 4. So that's square root for you. I'll comment square root so that I can look at another function. I want to look at the function POW, which is said is a function for power. So I declared two variables, but let me still leave my x. Alright, x is 4, y is 2. So I say C out POW, which is power, that is s raised to power y. So what's our x? Our x is 4, our y is 2. So 4 raised to power 2 is 16. So let's check the output. Beautiful. You can see 4 raised to power 6, 4 raised to power 2 is 16. So that is the power function POW. You provide the base and then followed by the power. So, okay, let's continue. The next function, I want to look at the ceiling function. Let me look at the ceiling function. What does the ceiling function do? Ceiling, just like if you look at ceiling, ceiling is above you, floor is below you. That's the concept. So when you talk about ceiling, ceiling is the next number, the next whole number above the value that you want to find each ceiling. So we have 6.5. What is the next whole number that is greater than 6.5? It's 7. So the ceiling of 6.5 is 7. So let's run it. Beautiful. So the ceiling of 6.5 is 7. Then take note of a negative value. Forgive it a negative value. What is the ceiling of minus 6.5? Somebody may be tempted to say minus 7. That will not be correct. The reason is that minus 7 is not greater than minus 6.5. Yes, 7 is greater than 6.5, positive number. But remember, in negative number, the lower number is higher or greater than the higher number. So if we have 6.5 as the value we want to find each ceiling, that is, what is the next whole number after minus 6.5? The answer should be minus 6. Because if you are going down, or if you are going up in the order of increment in negative direction, you see that after minus 6.5, the next number that is whole number that is above minus 6.5 is minus 6. Okay. My system is delaying, but it will come up. Good. You see? The ceiling of 6.5 is 7, while the ceiling of minus 6.5 is minus 6. Minus 6 is greater than minus 6.5, and 7 is greater than 6.5. Alright? So let's go for the floor function. The floor function. Let's go for the floor function. The floor function does the opposite of the ceiling function. So now for 6.5, what's the whole number that is below 6.5? Is 6. The whole number below 6.5 is 6. What of the whole number that is below minus 6.5? It's minus 7. Just the opposite of the ceiling value or the ceiling function. So let's look at it by expecting 6 and minus 7 in our output. Expecting 6. Beautiful. So the floor of 6.5 is 6, while the floor of minus 6.5 is minus 7. That is great. So we'll look at another set of functions. I'll be looking at the C-type function. So what I will have here is C-type. C-type. to upper. So maybe I will just declare character str is equal to small letter a, small letter a. Then I now want to see the output. Okay, let me just say character ABC is equal to upper, the character that we first declared, and I say see out. Let me see out the character. Then after that I'll just say end line for the next, and I'll declare ABC. So let's look at this code. If you look at this code in line 7, I declared a variable called str character, and the value is small letter a. Then I came back to say I declared another value ABC, and I said the value in ABC should be to upper what is in character A. So what I should be expecting in character ABC is capital letter A. So I now decided to display both of them, the first character and then the new character. So let's run and see. Oh, hash includes C type. Hash includes C type. That's giving me error. Sorry, let me see something. Alright, sorry, it's CC type, not just C type, CC type. So you can observe this capital letter A for character, and small letter A for character, and then capital letter A for ABC. So you see that to upper converts a character to the uppercase, while to lower converts it to lowercase. So we are going to demonstrate more because I want to be showing you more things. Let's assume that I want to just output the result to upper str. Let's see the difference between looking at this, the result should be the same. That to convert character to upper, I should, so what I'm expecting should be small letter. I'll display capital letter, then I'll display small letter and display capital letter. But let's see whether it will happen like we're expecting. Wow, it's not giving us what we expected. Where is 65 coming from? And it's coming from line 8 when we say, line 9 when we say display to upper character. It gave us 65 instead of capital letter A. But in line 10, yes, line 10 gave us small letter A for character and gave us capital letter A, the converted one from ABC. So what is happening? What happened? Good. What happened is that when you are dealing with character data type, take note that you are actually dealing with a number. If you remember your ASCII code, you know that every character on your keyboard has a number behind it. The number behind it is what the computer actually makes use of. The symbol is just what you are seeing as characters, but they are not what the computer makes use of. Remember, computer makes use of binary values. So for you to convert your characters to binary, it must first of all have them as number, because you don't convert characters to binary. It's numbers you convert to binary, decimal numbers or hexadecimal numbers. So these characters on your keyboard, they actually have codes behind them. We see them from ASCII code most especially. So the code for letter A is 65. The code for letter A is 65. So when I say C out to upper, I'm actually asking for that number. So for me to make sure that I get the character and not the number, I will have to do what we call casting. So I will cast it, that is to say, I will force it to give me a character instead of giving me a number. So with this now, character coming before the to upper function, I'm forcing that 65 to come as a character and not as a number. So let's see the output again. We're taking some time. Wow, okay. It took some time, but we got what we're looking for. So it is no longer coming as 65. It came as character A, then the small letter A for the character here, and then capital letter A for ABC. Alright, let me also shock you a little more. Instead of typing 65, instead of typing A, let me type 65. That will shock you a bit. 65 is actually the capital letter of A. So let's look at our program. Are we going to have anything coming as lowercase? Maybe yes, maybe no. But let's see. 65 is actually, from what we saw, is the code for the number, for the character A. So therefore, if we run this program, I think all our output are going to be all capital letter A. They are going to be all capital letter A. Several. Good. Does that surprise you? It shouldn't. Remember, I told you that the alphabet or the characters you see on your screen, they have a number behind them. So if I declare a variable as character and provide a number for it, yes, the compiler will accept it, because actually if I give it a character, it has to convert it to this number before it can make use of it. So it took it as 65, yes, but it uses it or displays it as a symbol. So in this case now, we are not going to be making use of to upper. Probably what we are going to be making use of is to lower, since what we have is an uppercase value. So I'll say to lower, then here to lower. I'll also remove the character, the casting, so I will see the value for what's the value for small letter A. We're going to see the value for small letter A. That should give us 97. Yeah. So you see, our value is 65. 65 is the value for capital letter A. Then we'll say ABC is to lower character. So that means if it is capital letter A, the new value we are going to get is small letter A. That's why we have C out. The first C out gave us character, which is capital letter A. The second one gave us ABC, which is small letter A. Then the one that gave us 97 is the one that we did not cast. So if we cast it now, and I cast it, forcing it to be a character. If I run the program again, we'll be seeing 2 small letters and 1 capital letter. What happened? Oh, sorry, that was not where I was supposed to cast. I was supposed to cast the output one, not this one. This one was one I was supposed to cast. Okay. I should see 2 small letters. Yeah. So it's no longer coming as 97. It now came as small letter A. Then the ABC came as capital. The character came as capital letter A, while ABC also came as small letter A. So these are just a few examples of the CC type data type. The CC type data type. So let's push ahead for another data type, the string data type. The string data type. Let me work with the string data type. So we're going to be maybe declare string name, call it a name. Okay, I call it, maybe name is John Paul. That's string. So see out, let's say the length of this character, this name. So we'll say length of name. You can either say length or you can also say size. So length or size, any of the two will work for you. So I'll just use the two. So you see that there are two ways you can do it. Size. So I want to see this John Paul, how many characters? Where is the error coming from? See out length. I think I misused it. It's not name should come before it. The value, the string should come. So it should be name.length and name.size. I think let's try it again. Name.length, name.size. Which error again? Okay, I have another extra this. It's taking quite some time. Good. So let's count John Paul. And then 9 characters. J-O-H. So J-O-H-N is 4. P-A-U-L is also 4. So 4 plus 4 is 8. Why 9? There is a space between them. So the space is also included. That's why it is 9 and not just 8. So you can use length and size to find the length of a string. So that's a length and size function. Then the next function I want to also do is the append function. Let me append. Let me say name dot append. I want to add a third name to it. John Paul Mark. John Paul Mark. Then I will now display. I'll see just do name dot length. Ctrl C. Ctrl V. I also see out the name. So let's see whether Mark was added to the John Paul. Let's see. Beautiful. The length is no more 9. The length is now 14 because of Mark and the space. So John Paul Mark append will help make you add a set of character or string to an already existing string. So I'll look at just one more before I call it a day. Let me say I want to pick some character from among. Let me just see out. Let me just go straight to see out. See out. Substring is a function. You want to copy or cut a portion of a string. So I want to pick probably John out of John Mark. I'm also getting it wrong at a point. It's name.substring. Name.substring. Okay? Let me see what it picks for me. Substring, where to start? Start from in the 0. Pick 4 characters. start from index 0, pick 4 characters. That's a substring. So I should be seeing John on the screen. I should be seeing John on the screen. Beautiful. So it picked John for us because starting from 0, if you count first 4 characters, is John. So what if I wanted to pick Paul? So where is Paul? Paul is on which character? This is 0, 1, 2, 3, 4, 5. So if I start from the 5th index, let me pick 4 characters. I'm picking Paul. If I want to pick Paul Mark, and Paul Mark, starting from Paul, which is the 5th character, and Mark is another 4 characters, that's making it 8 characters plus the space in between, so that's 9 characters. So I want to pick Paul Mark. I want to pick Paul Mark. Great. So we have just looked at a few library functions. Remember, we said when you want to use a library function, make sure you include the header file that contains the function. Yes, though some IDEs may not require that because somehow the compiler knows a way to handle it. But standard wise, whenever you want to use any particular function, you must include the header file that contains the function. So what have we learned today? We have learned functions. We said it's a self-contained code that performs a single task in a program. We said the essence is to help us not to reinvent the wheel again. We can write a code and reuse it instead of duplicating codes. And we said we have 2 types of functions. We have the library function and the user-defined functions. Today we just consider the library functions. We consider just very few. There are several of them. No one video can take all. No one, not even all that has to do with the math function, the string function, the C-type function. There are other functions, header files, that are included in C++. This is just to show you that first of all they exist, how they are used, so you can go to any textbook or go online too and study more of these library functions. They will come handy when you are writing programs that will require you to perform some very good tasks. Thank you so much. My name is Mr. Ifeanyi. You can subscribe to this channel. It will not cost you anything. Thank you so much, and God bless you.